If I were to take two different gases and put them in two different environments, different pressures, volumes, temperatures, different amounts of them, and I were to measure those aspects accurately. So let's say we take the pressure and the volume and divide it by the moles and temperature for this gas. And I were to do the same for the other gas. They would both end up equaling the same number, or at least be very, 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 very close to each other. This is known as something called the ideal gas law, where if a gas acts as an ideal gas, and most of them usually do under normal circumstances, then these traits, pressure, volume, moles, and temperature, when put into this equation, should always equal R, this same number. And R is equal to 0.0821 liter atmospheres over moles times Kelvin. And a lot of times we rearrange this equation to this, PV equals nRT. Some people call this Pivnert, just to remember how remember the formula. You need to memorize this. And what this allows you to do is if you know three aspects of a gas, you can solve for the fourth one. Since R is a constant, that's always going to be the same. If you know, for example, volume, moles, and temperature, you can solve for the pressure. Or if you know pressure, volume, and moles, you can find out what temperature the gas is at. So I want to emphasize here, I'm not dealing with changing a property of gas like we did in the last video. What I'm saying is that if I know various aspects of a gas, I can know the final property that I'm missing. So, for example, what volume will 5 grams of carbon dioxide occupy at 735 torr and 25 degrees Celsius? And we're going to assume carbon dioxide is an ideal gas. And because of that, I'm going to use the ideal gas law. And the problem is asking me to solve for volume. So let's manipulate this equation to solve for V. Now, if I just took the numbers as is and threw them in the equation, my answer would be very, very, very wrong. Because I have the amount of gas, but it's in grams. The ideal gas law says it needs to be in moles. I have a pressure, but notice R is in units of atmospheres. So I'm going to convert my pressure to atmospheres. And I have a temperature, but as usual, when we deal with gases, temperature needs to be converted to Kelvin. So let's work on those conversions first, and then we can throw that into our equation. So the moles of gas, we're going to start with the 5 grams of carbon dioxide. How do I go to moles of carbon dioxide? I'm going to use the molar mass, so I add it all up from the periodic table. And that comes out to 0.114 moles of carbon dioxide. Okay, let's deal with pressure. So I'm given 735 torr, and I know the conversion is that 760 torr make up 1 atmosphere. So that's 0.967 atmospheres. And then temperature, Starting at 25 degrees Celsius, I'm going to add 273.15. My temperature is 298.15 Kelvin. Now I have everything in the right units. So I'm going to throw it into the equation. I'm going to throw in my value of R. That's always the same for every ideal gas. And then temperature, all of that divided by pressure. And notice how my units cancel out. I got moles here. I got moles here at the bottom of a fraction. My temperature here cancels out with temperature at the bottom of a fraction. And then I have atmospheres at the top of a fraction and atmospheres at the bottom of a fraction. I'm left with volume. So throw this into my calculator, keep track of sig figs. That comes out to 2.89 liters. So again, I've already shown you like a couple of types of examples or problems where we're using various formulas. How do you know which one to use and when? When do I use the combined gas law like we did last time? Well, in this case, again, let me emphasize what we did here is we changed one of the conditions of a gas. And then we solved for what a new property would be. Using the ideal gas law is we know most properties of a gas, and we're solving for the one single one that we don't know. And that's how you know which formula you need to be using. In our last video that's coming up next, we're going to kind of look at some standard conditions that we generally make measurements for on a gas.